Dropping spices into high-heat oil creates an immediate, highly violent reaction and produces a massive volume of thick smoke. If you look closely at this diagram, you can see the hidden composition of that cloud. It contains hundreds of microscopic, aerosolized oil droplets, liquid grease suspended directly in the breathable air alongside gray smoke particles. Breathing this aerosolized grease degrades indoor air quality and poses genuine respiratory health risks over time. And if you do nothing, gravity eventually pulls those microscopic oil particles out of the air. They settle onto your walls, cabinets, and counters, depositing a permanent, sticky layer of grease on every exposed surface. Managing cooking smoke is a strict structural and health necessity. Figuring out how to do it efficiently launched a decades-long chain reaction of engineering problem-solving. The first iteration of kitchen ventilation was pure brute force, aiming a small desk fan at the stove to simply blow the smoke away. But this merely displaces the smoke. Instead of removing the oil particles, the fan accelerates their spread, coating the entire kitchen in sticky grease, instead of just the immediate cooking area. The logical next step was the wall-mounted exhaust fan, engineered specifically to pull that smoke completely out of the house. In the short term, this works. The interior kitchen air stays clean and breathable. The problem is that an exhaust fan lacks a filter. Every microscopic drop of that aerosolized oil passes directly through its internal mechanical components. Over time, thick grease accumulates on the motor and blades. The fan's operating noise increases significantly, and cleaning those fragile moving parts becomes virtually impossible. Early engineers successfully learned how to move the dirty air out of the kitchen, but they accidentally created a machine-destroying maintenance nightmare in the process. To protect the fan's motor, engineers introduced a third iteration, placing a physical metal mesh barrier directly in front of the exhaust intake. As this cross-section shows, the metal grid physically intercepts and traps the large oil particles, allowing only the clean air to pass through to the fan blades behind it. This combination of an exhaust fan paired with a physical grease trap represents a major historical milestone. It was the world's first true kitchen chimney. But because the mesh filter works so well at catching grease, its microscopic pores become clogged with thick oil almost immediately. This requires the owner to constantly disassemble the unit and perform intense manual scrubbing with harsh chemicals to restore the airflow. Early chimneys successfully saved our lungs and our kitchen walls, but they ultimately chained the user to the sink, trading an air quality problem for a manual labor problem. The modern auto-clean smart chimney abandons physical grease trapping in favor of autonomous thermal destruction. Inside the unit lies the core breakthrough. A specialized fan and pressurized spray system inject 110-degree steam, melting hardened grease off the walls. Then, the system blasts high-pressure water to wash debris away, finally triggering a heating element to dry the interior. Human interaction is reduced to simply managing two removable tanks, one providing the clean water and one collecting the dirty grease runoff. The appliance also utilizes spatial awareness, automatically detecting and pulling in residual smoke even after you finished cooking and stepped away. After exactly 7 hours of logged usage, the chimney initiates its own 6-minute cleaning cycle without any human prompting. The evolutionary journey from a desktop fan to a self-aware appliance ends here. Modern engineering removes the human from the maintenance loop entirely.